Hi students. So in this lecture we will talk about AC generator working of and the working of AC generator. Now as you can see in this figure sorry, the construction of the AC generator is something like this. You have a magnet with north and south pole here. Then you have a sort of a shaft with an axle at the top. The armature is of copper coil, correct? Now there are two ends of it. One is switch 1 and switch 2. They are connected to brush, and they in terms it is connected to load. Now very quickly, as we have studied in Faraday's law, change in magnetic flux linked with the conducting coil, results in induced EMF. And induced EMF, if it is a closed circuit, then it forms induced current. Now, see, these are the two ends of a large magnet with north and south pole. So there are magnetic field lines. Now, what happens is when this axle rotates, this shaft, the magnetic field lines in this shaft changes. Now when these lines changes, it results in in a flux, and flux results in induced EMF. So when it rotates, the current is generated. When the current is generated, it is something like this. It is rotating like this, as you see here, correct? So when it rotates, these magnetic field lines changes and current is produced. Now what happens is this is connected to a brush, and the function of brush is, because this is not, this is moving, because this is moving. So if it is a fixed joint and not brush, then it might break. So because of brush, it is very flexible, correct? Similarly here, now when it rotates, half of the cycle it is in one direction, the current is produced in the one direction. And when it crosses half, the direction of the current becomes opposite. So as a result, a alternating current is produced. I will explain you this again, but for now just take a note of the structure of this magnetic of this AC generator setup, and understand the concept that it is caused by Faraday's law. Change in magnetic flux linked with the conducting coil, induce EMF, and closed circuit and induce circuit. Now couple of things to note in this diagram which I have drawn here. So first thing is, this, as I said, is an armature coil of copper. As sometimes there is a soft iron core as well here. Soft iron core. So what this does is this increases number of flux line changes. Okay, now S1 and S2 is slip ring, which are of copper. Okay, now it maintains contacts between armature coil and brush. So this maintains contact between brush and armature. Okay, now B1 and B2 maintains contact between ring and load. So slip ring copper, and it maintains it maintains contact between armature coil and brush, between armature coil and brush. Okay, now B1, B2 maintain contact between rings and load, as you see in the picture here. Okay, okay. Now, to understand the working, let me reiterate, or let me tell you, or detail it for you guys. Now, as you see in the sheet right now, see, initially let's understand this armature coil is suppose perpendicular to the magnetic field lines which are horizontal as shown in this figure. Okay, now if it is perpendicular initially, let's start from there initially. After time t, it rotates, as you can see in diagram number 2. This is diagram number 1, this is in diagram number 2. It rotates by an angle theta. Okay, again I am saying, see, this is the, let's assume this as the initial position. In the initial position, north is here, south is here, and there is the armature coil which is perpendicular. So this is one magnet, let's say these are the two magnets, and these are the two magnets, and we have armature coil perpendicular to it, as you can see here. So initially at t is equal to 0. Now after some time it rotates a bit. How much? By angle theta. Now when it rotates by angle theta, I can say that, theta is the angle between A, which is area vector, as you know, area vector of this, and magnetic field, area vector of armature coil and magnetic field. Correct? So is theta at t is equal to t. Okay. Now assume angular velocity of this movement, angular velocity of this rotation is omega. Now omega can also be written as theta by t, or theta is equal to omega t. Okay, now let's talk about what is the magnetic flux linked with the coil at phi b position, or in this position. Okay, so magnetic flux, I can say magnetic flux linked with coil phi b is equal to b dot a, which is ba cos theta, because it's rotated in theta, but theta is omega t, so I can say ba cos omega t. Now if there are n terms, if there are n turns, then total flux phi net is equal to nba cos omega t. Correct? Okay. Now, after this step, we will just let me draw this like, okay, induced EMF would be E is equal to minus d phi by dt. Correct? If I put phi net, by the way. Correct? Or I can say it is minus d n b a cos omega t by dt. By dt. Further, if I just differentiate it, it becomes minus nba minus sine omega t, because the differentiation of cos is sine, into omega. Or finally, I can say E is equal to nba omega sine omega t. One more thing, in after this step we can put in place of these all things, or let me put it by a red pen. I can put this as E naught. So this becomes E is equal to E naught sine omega t, where E naught is equal to NBA A omega. Now we have this. So we can also find what current. Current is nothing but I is equal to this, which is E naught sine omega t divided by R, or I can say, if I put this as I naught, so I can write I is equal to I naught sine omega t. Okay, this can also be inferenced out after finding EMF. Okay, so this completes it. Finally, one last thing is, probably we can have a sort of a graph which can express it. So let me draw in this space available. Let's say this is the space, and the graph would be of the sine curve. So basically I is equal to I naught sine omega t, correct? And this graph would be something like this. I'm just drawing a miniature of this because of the space crunch. This would be what, 360-degree, correct? This is 270-degree. This is 180-degree. This is 90-degree, and so on. This is I and theta, correct? And we can also say, sorry, let me make it very clear. This is 90. Okay, I can say this is 0, t by 4, t by 2, 3t by 4, and t. Okay, so this would be the graph. So this finishes this, and in the next lesson we will talk about more in detail about AC circuits. Thank you very much.